Hello and welcome to this Ka Right question. It looks at an organic acid that you might not have seen before on the specification. It's from the Unified Chemistry 2019 paper from OCR Chemistry A. It's question 4A part 4. So let's first of all look at processing the question. We've got this structure up here for chloroxylenol, and we know that the student measures the pH of the contents in a bottle of Dettol. So Dettol contains this substance. So it gives us quite a lot of information, and it wants us to calculate the acid dissociation constant for chloroxylenol, as well as writing the equation using molecular formulae for the acid dissociation of this compound. So looking at it, we can do something with the fact that the pH is 5.14. We can do something with the fact that 100 centimeter cubed of Dettol contains 4.80 grams, and also there's some information here. Because the chloroxylenol is a weak monobasic acid. It's also the only acidic component in Dettol, so the pH in Dettol doesn't come from anything else. So let's start down here, and we can write a Ka expression. Now in the Ka expression, we have three things. We have the H plus ion concentration, we have the concentration of the chloroxylenol, and we have the concentration of the conjugate base. So therefore, we can start with the H plus concentration. And to do that, we can work out the H plus concentration from 10 to the minus pH. The next thing to look at is the fact that 100 centimeter cubed of Dettol contains 4.80 grams of chloroxylenol. So, in other words, the concentration of chloroxylenol, which is given in moles per decimeter cubed, the decimeter cubed being 1000 centimeter cubed, the number of moles of C8H8OCl in 100 centimeter cubed is 1/10 of the moles in 1 decimeter cubed. So if we can get the moles of C8H8OCl in 4.80 grams, multiply that by 10, then we have the concentration. And finally, the chloroxylenol is a weak monobasic acid. So therefore our equation can look something like this. Remember, we're sticking to molecular formulae. So now let's construct the answer using those reductions we've just done. So starting with our Ka expression, we can calculate the concentration of H plus ions by doing 10 to the minus 5.14. Remember, this was the pH. Now using the structure, we can construct the molecular formula for this compound, and using the periodic table work out the grams per mole. Dividing the mass present by the grams per mole gives us the moles in 100 centimeter cubed, and multiply this number by 10 gives you the moles in 1 decimeter cubed. So therefore you can express the concentration of chloroxylenol in moles per decimeter cubed. So simplifying the Ka expression, we don't have to worry too much about the number of moles of our conjugate base, because remember, the conjugate base and the H plus ions are made in equimolar quantities because it's a monobasic acid. So therefore H plus squared can substitute in instead in the numerator. So what we can do is square the value for H plus that we've got, and we can insert the value for C8H9OCl, which we worked out up here. So 1 divided by the other gives us 1.71 times 10 to the minus 10 moles per decimeter cubed. I'm not forgetting that we actually need to write an equation using molecular formula only. We write out C8H9OCl, we put in the equilibrium sign, because remember it's a weak acid, and then you have C8H8OCl minus and H plus state symbols throughout. Okay, hopefully this has been a useful look at this kind of question. As always, thanks for listening. Until next time, see you soon.